In this video, I'm going to go through some of the harder questions raised in the 2018 longer answer paper. Remember, if you want to do well in this test, you need to practice as many past papers as you can, go through the answers and try to find out where you've gone wrong if you do go wrong. Remember, please do email me asking me if you need any help with anything. I'm happy to do another video on this. Right, question 2 was raised as a hard one. First of all, the equation for work. You need to know this. Remember, work done, or work, is equal to force times distance. Don't just write distance because it's the distance moved. Otherwise, you don't know what distance you're talking about. Is the distance from here to the moon? Or is the distance moved? Learn that. Write it in words. So, knowing that, I can now calculate the work done. Now, I'm going to show you how I approach these questions and how I read them. It's quite an important technique, not just to rush in, but to see what they give you. They give us a force, and they give us the value there, and they give us a distance that's moved. So this basically moves 12 meters, and this person's giving it a force of 400 newtons. Well, if we look at our equation in part A, we can see that the work done, which has the symbol W, remember you need to learn that one, is the force, 400, times the distance moved, 12, and that will give you your answer. Remember, you're going to have a calculator in the exam, feel free to use it, or this one should be able to work out in your head. It's 4,800, and don't forget the units. Units of work done are joules, or you can just write a J like that. So that'll be 3 marks there. Let's have a look at the next one. So Xavier drinks an energy drink. The nutritional information is shown below. Let's see what goes on here. So state the form of energy supplied by the drink. Remember, this is chemical. So when it says state the form of energy, it means the type. Remember those types you learned? You could learn it as most kids hate learning GCSE energy names, and each of those letters stands for something. So it's gravitational, kinetic, and all those types. But in food and drink, it is chemical. Xavier drinks 200 milliliters of the drink. Calculate how far Xavier would need to pull the tire to use all the energy he drank. Okay, so they're the keywords in there. First thing to note is he drinks 200 milliliters. And if we look at our nutritional information up here, this is per 100 milliliters. It tells you how much energy you get for each 100. So the first thing to do is work out how much energy there is in 200 milliliters. So the energy in this amount is going to be twice what the packet says, so twice times 192. Again, type that into your calculator to make sure you've got no mistakes. And that tells you it's 384. When you look up here, the units were kilojoules, so this is going to be in kilojoules. Hopefully you remember for notes quest, K, kilo, means 1,000. In this case, this can be written as 384,000 joules. Okay, so this is how much energy there is in the drink. We haven't answered the question yet, though, because it asks you how far can Xavier pull the tyre. Well, this time we're going to use the equation work done equals force times distance. We're going to rearrange it. Distance equals work done over force. Now the work done, well, is going to come from the chemical energy of the drink. So that's 384,000 joules. The force, as we found out in the question before, that Xavier can apply is 400. So we divide the two. You get 960 meters as the distance Xavier can pull out. Because remember, all that energy that goes into pulling the tire, that distance, is going to come from the chemicals energy in the drink. State the law of conservation of energy. Remember, this is that energy cannot be created or destroyed, only converted from one form to the other. So it's the idea that energy cannot be created or destroyed, only transferred from one form to another. So just learn that one there. Scrolling down, let's now have a look at question 9, was the other one that was raised as being quite difficult. A student constructs a circuit below, so we're now on electricity. State the current at point X. So there's point X. Well, remember, look at this circuit. What type is it? Well, hopefully you remember it's a series. And remember, the current is the same everywhere in a series circuit. Why? Well, if you think the electrons flowing out of here, now remember that's important, electrons flow from negative to positive. They come out the negative terminal because they're negative, and they flow around. They can't just disappear. So whatever flowed past here has got to be the same there. So the answer must be 4 amps. It's got to be the same. If it was parallel, then it would share or split between the branches. State the voltage measured across the resistor at Y. Well, the same rule for, the rule for series circuits for voltage is the opposite to current. The voltage is shared when in series. In this case, we have 12 volts. This is going to be shared 6 volts between the two. So the answer is 6 volts. 6 plus 6 gives me the 12 coming out of the battery. You can't just have voltage coming out of nowhere. Whatever the battery provides is going to be used in the circuit. If I had another resistor in here, well then they'll all get 4 volts each. Let's take the current at Z. Right. So what's happened here is we've got this circuit from the start up here, but they've doubled the voltage. The voltage of the battery is twice as big, so it's going to create twice as much current. But also, with 2 resistors in parallel. Now think about this, if you have one door in a house, you can kind of flow out quite easily, but if you have 2 doors open, you can flow out twice as fast because there's 2 ways. So with 2 parallel branches, there's going to be twice the current compared to part A. So when you do twice current because of the battery being twice as powerful and twice because it's in parallel, so you're timesing your answer in part A, which was 4, by 2 twice. So 4 times 2 is 8, times 2 again is 16. So we should have 16 amps. Explain using the term electrical energy, the difference between EMF and potential difference. As I say, you can just have a look at the answers to this for that. I'm not going to go through this in too much detail here, but remember the idea that potential difference and EMF, they're both voltage, and the definition of voltage is the amount of energy per unit charge. So that's energy per unit charge. So you need to make sure that answers in your answer. So energy per unit charge. Okay, have a flick to the answers. As I say, they're just there's the document